Welcome back, everyone. For years, the search for life beyond Earth has felt like a long shot. We've found thousands of exoplanets, planets orbiting other stars, but most were either too hot, too cold, or just plain weird. We had the Goldilocks zone, a tidy theory that said if a planet was just the right distance from its star, it might have liquid water and therefore life. But now, our best instruments, like the incredibly powerful James Webb Space Telescope, are allowing us to do something we've never done before: peek into the atmospheres of these distant worlds. And it's what we found on one of them, called K2-18b, that has the entire scientific community buzzing. It's a discovery so significant, it could be a paradigm shift in our understanding of the cosmos. So what exactly is K2-18b? It's what scientists call a super-Earth, a planet bigger than Earth but smaller than Neptune. It's about 8.6 times the mass of our planet, and it sits comfortably in the habitable zone of its star, a dim red dwarf. This means it receives just the right amount of light and heat to potentially support liquid water. For a long time, we knew it was a promising candidate, but that was just the theory. The game changed with the James Webb Space Telescope. By observing K2-18b as it passed in front of its star, Webb was able to analyze the starlight filtering through the planet's atmosphere. Think of it like a cosmic fingerprint. And in that fingerprint, they found two incredible signatures. First, they found water vapor. This was exciting but not completely unexpected. But the second chemical they found is what truly sent shockwaves through the scientific world: dimethyl sulfide, or DMS. Now, if you're not a biologist, that name might not mean anything to you. But on Earth, DMS is produced almost exclusively by living organisms. Think of phytoplankton in our oceans, for example. It's what gives the sea its distinctive smell. The concentration of DMS they found was massive, 1,000 times higher than on Earth. And because DMS is a highly unstable gas, it gets destroyed by sunlight very quickly. This means for it to exist in such high concentrations, something must be constantly replenishing it. And the most logical explanation, with a 99.7% probability, is active large-scale biological production. This isn't a guess. This is a robust scientific finding that suggests K2-18b is not just a rocky planet with a bit of water vapor. It's a probable Heisen planet, an ocean world covered in a thick atmosphere, with a deep, dark sea that may be home to life forms unlike anything we can even imagine. While K2-18b is the star of the show, it's not the only promising lead we have. We're also studying other planets that redefine what we thought was possible for life. Take Teegarden b and Kepler 1649c, for example. They're both located in the habitable zone, but they have a unique challenge: they're tidally locked. This means one side is in perpetual day and the other is in perpetual night. Sounds like a nightmare, right? But scientists theorize that there could be a narrow band, a kind of twilight zone on these planets where the temperature is just right for liquid water. Life, if it exists there, would have adapted to a permanent sunset. Then there's TOI 700d. It's almost a perfect Earth-sized match, orbiting its star in a way that gives it a normal day-night cycle, which increases its chances of supporting a stable climate. The diversity of these planets shows us that the rules of habitability are far more flexible and fascinating than we once thought. The universe is full of different recipes for life, and we're just starting to read the cookbook. But it's not all about finding life. Our exoplanet discoveries are also revealing just how truly strange and extreme the universe can be. These worlds defy everything we thought we knew about planetary formation. Case in point, J1407b. Nicknamed Saturn on steroids, this planet has a ring system so large it would dwarf our own. Its rings are 200 times wider than Saturn's, stretching for over 100 million miles. If you put it in our solar system, they would dominate the sky, shining brighter than the moon. Then there's WASP-76b. On this ultra-hot world, the dayside reaches temperatures of over 4,000 degrees Fahrenheit, hot enough to vaporize iron. That vapor gets carried by winds to the cooler night side, where it condenses into liquid iron and then rains down from the sky. Literal molten iron rain. And believe it or not, there's a planet made almost entirely of diamond. PSRJ 1719-1438b is a dense former star that's been stripped down by a pulsar. Its incredibly high pressure and extreme heat have turned its carbon into a giant, sparkling diamond planet. These discoveries are not just cool to look at, they're fundamentally changing planetary science. They are forcing us to rewrite the textbooks and expand our theories on how planets form and evolve. The journey is far from over. The detection of DMS on K2-18b is incredible, but to achieve a definitive 100% confirmation, what scientists call 5 sigma confidence, we need more data. Future missions and even more powerful instruments will be crucial to ruling out all other possibilities and confirming a biological origin. The stakes are incredibly high, and the scientific community is moving forward with cautious optimism and rigorous peer review. The biggest takeaway from all of this is that the universe is not just vast and empty. It is a place of endless possibility, where life could be thriving in countless forms on millions of planets we have yet to discover. The detection of a moon-forming disk around a planet called PDS-70c even gives us a glimpse into how moons might form around these distant worlds, which could further impact their ability to host life. The question we've asked for centuries, "Are we alone?" is no longer a philosophical one. It is a question that we are now on the verge of answering. The universe is a far more diverse and vibrant place than we could have ever imagined. And thanks to breakthroughs like the one on K2-18b, we are finally starting to find our place in it. If this incredible journey into the cosmos fascinated you, you're not going to want to miss what we talk about next. Be sure to hit that subscribe button and click the bell icon so you don't miss our next video, where we dive into the strangest black holes in the universe. And I want to hear your thoughts. What kind of alien life do you think could exist on a planet like K2-18b? Let me know in the comments below.